In this video, I'm going to work on the ALEKS problem called Naming Alkenes and Alkynes. This problem is going to give us three molecules, a combination of either alkenes, which are molecules that have carbon-carbon double bonds, or alkynes, which are molecules that have carbon-carbon triple bonds. We're being asked to name all three of these molecules. I think I'm going to start with the one on the end here. I think this is the easiest one to do. We'll do this first. Our first job is to find the longest continuous chain of carbon atoms that contains the triple bond. So there it is right there. And then we're going to number that chain of carbon atoms so that the triple bond is spanning the smallest numbered carbon atom. So I want to number it from right to left so that my carbon-carbon triple bond starts at 1 and goes to 2. If I numbered it this way, my carbon-carbon triple bond would be starting at 3 going to 4, and I want the smallest possible numbers. Next, I'm going to locate and name my substituent. This molecule has a substituent on carbon number 3. It is a 3-methyl. And now I'm ready to name the molecule. This is a 4-carbon chain. We know that 4-carbon chains are typically called a butane. This is a molecule that has a triple bond, so instead of calling it a butane, we are calling it a butyne. That ending YNE is used to indicate the presence of the alkyne, the carbon-carbon triple bond. We also have to say the location of the triple bond, and we're going to do that by putting the starting carbon of the triple bond, carbon number 1, we're going to put that in front of the ending of the molecule's name. 3-methyl means that we have a methyl on carbon number 3. But means that it's a 4-carbon chain. Ine means that there's a triple bond in that carbon chain, and 1 tells us where the triple bond starts. Let's try the one up above it. Let's try this one right here. We need to find the longest continuous chain of carbons that contains or includes that carbon-carbon double bond. So I'm going to go this way. We could also go this way. It's the same molecule either way. We need to number that chain of carbon atoms so that the double bond is getting the smallest possible number. So I want to number this way so that my double bond is going to start at carbon number 1. If I numbered the other way, numbered this way, my double bond would be starting at carbon number 2. And again, I want the smallest possible numbers. Locate your substituent. The substituent is on carbon number 2, and the substituent's name is methyl. Locate the starting point of the double bond. It starts on carbon number 1. This is a 3-carbon chain, which is prop. This is an alkene, so the suffix is -ine for alkene. And if you look carefully at the one up above it, look at what ALEKS has done for me. It has actually given me 2 of the exact same molecule in the same problem. This is also 2-methyl 1-propene.